Hello, my name is Lucy Cameron. I am the director of product for Haven. I've worked here for about 7.5 years, so I've seen the company go through all kinds of ups and downs, and we're really excited for where we're at right now and being able to launch an active air management system like this. Um, our vision is really to be able to proactively care for and address the ongoing comfort, health, and safety of our indoor environments because we spend so much time in them. And so we believe any control system should what we call care. This means having the system be comprehensive, adaptable, reliable, and efficient. So I can't tell if my video is turning on and off. Is it okay? I guess it doesn't really matter if we're looking at the slide anyways, but
It's working.
It's clear to me.
okay. So currently we have dedicated our product to the residential market, as there hasn't really been a great way to have sort of the centralized method for controlling the balance of comfort, health, and energy efficiency until now. We're looking to commercial systems for inspiration as they've had their building automation systems in place for many, many years. Our Wi-Fi connected hardware gets installed alongside the HVAC system of the home and has several different sensor and controls components, which require simple 24-volt power sources so they can run on external transformers or off of the air handler's transformer or control panel. Our controller, what you can see in the bottom left corner, it's sort of the candy bar shaped piece. This has two 24-volt dry contact relays, so it can connect to most types of HVAC and IAQ equipment like ventilation systems, the air handler blower fan, humidifiers, dampers, you name it. So having this sort of integrated controller allows us to be able to schedule the air handler blower fan on a regular cycle so that we're circulating the air in the home, preventing it from being stale, but also so that the monitor itself can regularly sample that air in order to determine whether it needs any sort of other treatment. If there is, say, a rise in particle levels, we would keep that system running, making sure that we're filtering as much of those particles out as possible, or say there's a chemical event, we would want to open up an outdoor damper to bring in that fresh air. So this sort of describes how the data gets processed and fed through our logic algorithms through the controller, creating this closed loop system, really creating that demand controlled management of the air in the home. So one of the beauties of this is that it's completely brand agnostic. So it doesn't matter if you have air handler from one company, dehumidifier from another. We can string those together and have them talking and working together as a system instead of these disparate arms that might inadvertently have conflicts with each other. So another thing is that the whole system is professionally managed by HVAC service companies. They're the perfect user to be able to manage the systems inside a home because they have the HVAC knowledge, they're learning about indoor air quality, they have building science knowledge, and we're actually trying to translate a lot of that from like the high performance contractors to the majority of contractors that may not have all of those insights. So the pros can really make use of the data that we can provide through what we're calling the Haven Pro portal, allowing them to back up and optimize the services and equipment recommendations that they're providing their homeowners. So we're kind of creating between homeowners and pros this shared language that we can start to build trust on going forward. So we can go to the next slide. So how are we currently addressing these different, oh, sorry, there's a typo, tenants. Haven currently optimizes how HVAC and IQ equipment is activated efficiently throughout different seasons. So this is in terms of the demand controlled operation, as well as adapting to outdoor conditions, because we're pulling in all kinds of outdoor weather data as well as pollution data, and those help us inform when we want to be controlling for ventilation, opening and closing those dampers to reduce load on the system and whatnot. I'll be speaking a little bit more to that on the next slide. In terms of load management and demand flexibility, because we're creating the centralized control system, there are definitely opportunities that we can see in the future to help stagger the usage of equipment that consumes a lot of energy through these high demand periods. And currently, the homeowner controls, and even the pro has a little bit of that remotely as well. They have the ability to turn the systems on and off if they see fit. For instance, maybe the pro has determined that there is some kind of issue. They can temporarily cut any activations from happening until they're able to roll a truck and service that equipment. So preventing any unintended harm to the home itself or otherwise. And then in terms of consumer amenity, we're currently redesigning our whole homeowner experience to include much more customization of what the homeowner's top issues are to prioritize in their home. And this could be based on the family or home preferences. Some homes may be more focused on maintaining health and or comfort, and then others might be leaning more towards the energy efficiency side of things. So we want to be able to have that inform how the system is running. And finally, from a security and privacy standpoint, we have very strict guidelines for how the data can be shared between homeowners and pros as far as the service companies, and we're striving to provide homeowners with as much control over their data as they like. Next slide, please. So in terms of the current applications of the product, as described in our first slide, the ability to connect these different types of equipment, have insights that are professionally managed, opens up the door to many different applications. And the ultimate goal is to improve on the indoor air quality in homes, resulting for better comfort and health. And we want to achieve this while keeping energy efficiency in mind. There's always that balance. So our control system allows for demand control activation. So we're operating the systems only when needed, not on fixed schedules. So for instance, having the dehumidifier run unnecessarily throughout the day unless it hits that set point that triggers it. We have equipment conflict prevention. Let's say with humidifiers and dehumidifiers, if those are on separate controls strategies, what's preventing them from running at the same time? So there's a lot more thought that is needed to put in if these are, like I said earlier, those disparate arms that are potentially causing equipment to run simultaneously. We have a bunch of great constraints in place that reduce that opportunity. We also prevent the system strain. So we're trying to optimize the runtime during times when the outdoor conditions may not be as favorable by automatically closing outdoor dampers and preventing mechanical ventilation from running, and instead simply circulating the air within the home to dissipate events and still have some effect on the health of the occupants. And then finally, in the pollution control area, we can look at the outdoor air quality, like I was saying before, have that be an input for our ventilation logic to prevent any additional problems from entering the home. So we don't want to be thinking that we're bringing in fresh air, but really it's wildfire season and we're just introducing a lot more harm into the home. A couple things that are sort of launching soon that we're really excited about are our smart humidity set points. And this will look at those outdoor temperature inputs and allow us to reduce the indoor humidity set point through cooler seasons in order to reduce condensation on windows and doors, and thereby reducing moisture and mold risk. This also optimizes system efficiency by avoiding unnecessary equipment operation. And without this adjustment, occupants may open a window to combat moisture buildup, and thereby introducing cold air that forces the system to recondition the indoor environment over and over and over again. So we're trying to proactively manage the humidity while minimizing for manual intervention, creating this sort of behind the scenes system. Another great one is for the control of low fan speed versus high fan speed. So because we have those two dry contact relays on the controller, we can have one hooked up to the low fan speed and one onto the high. This allows us to circulate the air using the low fan mode and then kick it into high fan speed for quick mitigation of any indoor air quality problems. As we all know, blower motors are a significant source of energy usage, and this approach allows us to really target, like, what is the purpose for having that equipment activated right now, and be able to address it sufficiently. A couple of future projects that we have sort of on the go right now are looking at the analysis of the duty cycles of an air handler and be able to provide HVAC diagnostic insights to the service companies. So hoping to help them predict when service maintenance is needed. And then another pilot is underway to develop more advanced algorithms in order to optimize these duty cycles and balance the indoor conditions with sort of these hot and cold pockets that we know to be existing in our spaces, and just trying to keep the health side balanced with the efficiency side.